Have you ever wondered how far water will shoot out of a 2-liter jug when a hole is poked in the side?
Who cares?
Well, my physics professor does. So I'm Leah.
I'm Michael.
I'm Jacob.
And we're going to show you how.
The first part of determining how far the water will shoot out of the bottle is finding the total pressure. This is found by multiplying rho, height, and gravity. In our case, this is 1,000 kilograms per meter cubed, 10 centimeters, and 9.8 meters per second squared. When multiplied out, this brings a total of 980 pascals, and added to 1 atmosphere, we are left with 102,280 pascals total.
Using the pressure that we just found, we were able to solve Bernoulli's equation for the final velocity. This equation resulted in 2 times the quantity of total pressure minus atmospheric pressure plus rho times gravity times height, which is the pressure of water at our selected height of 10 centimeters, all divided by rho, the density of water. Substituting in the total pressure of 102,280 pascals minus the atmospheric pressure of 101,300 pascals plus the pressure of water at our selected height, which is 980 pascals, and dividing by the density of water, 1,000 kilograms per meter cubed, resulted in 3.92 meters squared per second squared. Taking the square root of this led us to the final velocity of 1.979 meters per second.
After knowing the height at which the water will leave the bottle, we needed to find the time it would take before the water hit height 0. To find the time, we used t equals the square root of 2 times the height divided by 9.8 meters per second squared, which we derived from the distance formula d equals v naught times time plus 1/2 at squared, where v naught is 0 meters per second. So the square root of 2 times 0.1 meters divided by 9.8 meters per second squared equaled 0.1428 seconds. After finding this time it took for the water to hit height 0, we used v initial plus v final divided by 2 times time to find the distance the water will travel. So 0 meters per second plus 1.979 meters per second divided by 2 times 0.1428 seconds equals 0.1413 meters, which also equals 14.13 centimeters.
Now that we have an idea of where the water will land, let's see how close we are. In the experiment, some sources of error included the heights in the bottle being slightly off and drag on the water leaving the bottle. Once the experiment was conducted, the water landed between 13.5 and 14.5 centimeters, well within the theoretical result of 14.13 centimeters in the middle.